This is the second in the group of videos that's going to be preparing people for GCSE mathematics in the summer. Again, bite-sized chunks, around half an hour or so, no longer. This one will be particularly quick. Today's topic, as you can see, is going to be on loci and constructions. If you're working on this on YouTube, please click that like button and subscribe. And if you're watching the topics on Twitch, then please can you suggest topics for future by putting in your comments on the chat frame, which you'll find to the side of the video. So today we're working on loci, and you can see in front of you I've already pre-populated a loci question. This is very similar to a lot of exam questions that you will see. Again, just like last time, I want to show you a quick snippet of what I would normally show a group of students if I was working with a particular group of people. So here is a PowerPoint slide which you can see here, just pointing attention to some of the loci that you need to be aware of. This first one is obviously a circle, but it's the language that's quite important. So this one's talking about the locus of the point, equidistant from a point. What does that mean? It means everything in that circle is equal distances from the centre. A typical example might be tying your dog up in the back garden, fixing them to a pole, that sort of thing. So you can see that's a circular path. That one you certainly got to be aware of because it's used quite a lot, and we'll see it today. This one here is the perpendicular bisector. I'll show you how to do this today. It's very straightforward. You'll definitely need a compass though. You don't need a ruler except to draw the start line, that's it, and to draw the construction line at the end. But compass is really important, so make sure you have a compass with you. This is to do the locus of the point equidistant from 2 points. So the typical question that you might see is to sort of draw, I don't know, something like the placement of a runway between two towns, or to look at a street which is going directly between two cities, something like that. Those sorts of things are very commonly answered by doing perpendicular bisectors, and again we'll see that today. And then this one here is an angle bisector. So that is the points that are the same distance from two different lines, so particularly two different lines. So if you hear mention of two lines in a question, then usually you'll need to use the angle bisector. Again, you'll see that used today, and I'll show you how to do it. Again, pair of compass is pretty vital for this. This is just to show you some of the loci questions that you might get. This particular one is a favourite of mine. I call this one the radioactive shed. So imagine this grey blob in the middle is a radioactive shed, and that sort of circled line around it is where you can't go really, the exclusion zone around that radioactive shed. The key message here in this particular slide is just to make sure that you're aware that on the edges you're always going to have some curves, particularly at the corners there, each of the four corners producing a curved edge. And you can see here I'm using a scale, so 1 centimetre is what I'm indicating on. I would suggest that probably would represent 1 metre in real life. So you can see that circle in all of the corners around to make that sort of ovally shape. Similarly here, this is another diagram that you often see. We call this an ellipsoid, like a squash sausage. Really, it's the key question is, this would be sort of a goat tied to a pole, something like that, going up and down the pole, fixed to the pole with a lead. But where can the goat eat the grass in the back garden would be a sort of typical question that you might see for this. And again, it's just the key message is that when it gets to the end of the pole, the goat sort of draws a semicircular shape, so you get an ellipsoid, a sort of squash sausage. So back onto the exam questions, and let's talk a little bit about the exam question that you've got in front of you here. So this is asking you to use a ruler and compass to construct the perpendicular to the line segment AB that passes through the point P. And it says, very importantly, you must show all construction lines. That's very important for all loci questions. You'll always need to show your construction lines. So I'm just going to show you here, I've got my compass. Here's my compass. And I'm just going to put that into basically a set mode, so you can see me using the compass as I go around. The point I will draw attention to is just here, this point P. So what I'm going to do is I'm going to place this needle here on the point P, and I'm going to draw a couple of arcs. It doesn't matter what distance you are from P as long as they're on the line. So I'm going to draw a couple of lines here, just a couple of arcs, make sure they're on the line. So I'm going to draw those in, so you can see me doing that here and that over there. So you can see the two arcs I've just drawn. You can see that just there and there. And again, with the compass now off the page, I'm going to sort of make the compass a bit longer. It has to be longer than halfway. So I'm going to place the needle in one of the arcs here, place it a bit longer than halfway, always a bit longer than halfway, and I'm going to draw an arc. and I'm going to place the compass again without changing the compass. That's quite critical. I'm going to take the compass off the page, put the needle over here on this arc now, and I'm going to draw an arc again. And again, you can see that flicking in to there. And then obviously with a straight ruler, you're going to draw a line that's going to go straight down here. I'll use the compass pencil to do that, so just bear with me a second while I get that done. And that will give you the line there. And you can see that what I end up with is a straight line going straight through P. And it's asking me to draw a perpendicular. It's very important to recognise that this line here is 90 degrees from the line. We can show that by a little square there. That's going to be 90 degrees from the original line. So that's how you construct a perpendicular, not a perpendicular bisector, just a perpendicular. So 90 degrees to the line. So the two arcs, very important to start with, and then obviously drawing the two arcs there and then joining them up with a ruler. So that was quite a straightforward example. How can it get more difficult? As I mentioned earlier, they might ask you to do one of these. So this is a perpendicular bisector this time. It's very important to recognise that difference. So this time talking about a perpendicular bisector, and again, just like the slight difference, it does say again you must show all your construction lines. So we're going to just roll it down a little bit to show you how I draw the construction lines and show you how this is put together. So again, my compass here, I'm going to start from the end of the line this time. So very important to start from the end of the line. And again, the compass needs to be just a little bit more than halfway. That's quite critical. If it's not more than halfway, it will be much more difficult to do it. So you've got to get a little bit more than halfway. So I'm going to draw an arc there. And again, without resetting my compass, I'm going to take the compass off the page, put my needle at the other end of the line this time. So here am I putting it on the other end. Just need to get that lined up slightly. And I'm going to repeat the arc here. Sorry, my hands are getting in the way, but you can probably see what I'm doing. So there you go. I've joined the two arcs together, and these two arcs form a line, which when we join this up, and I'll just get my ruler and join that up, you will get a straight line. And again, what's key about this straight line is it's not only at 90 degrees like the previous question. This one will be halfway through your line. So just check that for you, just to show you how that works. So here's my ruler here. That's showing around sort of 7 centimeters. You might see that, and this one over here should be exactly the same. And again, yeah, just about 7 centimeters. You can see. Okay, so both sides exactly the same. So this is perpendicular. It's bisecting this distance. That's what they call a perpendicular bisector. Just definition there: perpendicular bisector. Similarly here, again, just a straightforward question. These are all straightforward questions to start with. Very much more towards the beginning of your exam, you should expect these sorts of things. This is asking you to draw an angle bisector. It's done it a bit back to front, so they're asking you to construct a bisector of the angle rather than the angle bisector, but hopefully you can put 2 and 2 together and make 4. These are two lines that you've got to look at, so obviously we're trying to draw these a bisector between these two lines, so that's very important to get that right. How do we do that? Very, very simple. Just set your compass. Doesn't matter what distance, set it to any distance you like. As long as it's within the breadth of the line. Stick your needle on Q, so I'm sticking a needle on Q this time, and again I'm arcing without changing the compass. That's quite critical. I'll slip slightly, so let's just start again, sorry. So that goes there and there. Okay, and again take your compass to the page. Critical again not to change your compass, so leave your compass alone. Don't change your compass once you've done the first pair of arcs. And again, you just place the needle in each of the arcs, and then they should join somewhere over here, and you can see them joining together. And again, you join that arc to the Q point here, and then once you do it right, just try and get as accurate as I can. Quite hard with the camera in the way, but you can do it there. And again, what's critical about that line is the angle on this side will be exactly the same as the angle on that side. And this will be an angle bisector, so it bisects this angle. This angle in here, let's say it was sort of, I don't know, 75 or something. This angle on each side will be equal of that, so 75 divided by 2 on each side. Okay, so in each time you're going to draw this shape, you're definitely going to get the same angle on both sides. What you mustn't do is use a protractor. It must be constructed using your compasses. This one here again, very straightforward question. Just asking you to draw a equilateral triangle. The reason I picked this one out is to do something a little bit later with you that I'll show you. But this one's asking you to draw an equilateral triangle of side 5 centimeters. Well, you can see there's one of the lines drawn for you there. That's a 5 centimeter base. You just got to make sure that with the ruler, you're going to draw. You're going to make sure your ruler is set to, or your compass is set to 5 centimeters. So again, I'm going to do that real quick. I have to go off camera just to do that because it takes a bit fiddly to do it. But hopefully I'll get that done. There we go. And then again, placing the compass needle at either end, you're just going to draw an arc, very straightforward arc, somewhere up here. Same the other side, don't reset your compass, leaving it at 5 centimeters, and they should cross somewhere like there. So you can see that's very faint, I know, but if I pull it up you'll see it's doing quite well. And then again with your ruler, just join them up to the sides of your line, to the corners. And that should be a 5 centimeter line. We'll measure it just to check, but it should be 5 centimeter line because of course that's what you set on the compass. And this should also be a 5 centimeter line, and because we had a 5 centimeter base, that makes for a 5 centimeter equilateral triangle. I'll just double check. That is indeed 5 centimeters, and that is, and then this one over here again, and that is just about 5 centimeters. It's fine. There is a parameter. There'll be a sort of margin of error they'll let you have in the exam. You haven't got to be totally 100% accurate, but as accurate as you can. And of course, the key thing they're looking for is these arcs again. You must show all your construction lines as it says in the question. So how does it get more difficult again? So this one again, slightly just easing up the difficulty level as we're going through these examples. This one here is using a ruler and compasses to construct the perpendicular, this time from the point C. So slightly different because this point was earlier on the line, if you remember from the previous example. This time it's up above the line. This time again asking you to draw the construction line. So how do you do this? Well, first of all, set your compass needle to C, and then you've got to set your compass to a breadth that's going to hit your lines a little bit more than just the line, so you can actually hit the line. And again, if you place your compass needle at C, so I'm going to do that real carefully there, and again you're going to draw an arc so that it hits the line, so you can see me doing that, so that it hit the line there and there. You can see that doing that. So again, I'll tip it up just so you can see that. It's come out a bit fainter than I was hoping. So hit the line there and there, and again we're gonna just take our compass, take the compass off the page, place the needle where the arcs have crossed, and you will see that I haven't reset the compass. That's also very important, so don't reset the compass. If I draw an arc there, and again below, same, so above and below, and then again this one here, above and below. Okay, I've just got it off slightly off camera, but you get the idea. Okay, so you can see above there, and there's one below there as well, which you will see, and they'll join you up, and you can join them up and you make a perpendicular. I'm just going to show you that real quick just so you can see that, because it's not come out very well. So I'll just show you where it is again. So I'll just redo that one at the bottom just so you can see it. So again, without resetting the compass, above and below, so you can see I've made that, and then above and then below. Just do that again here. Not resetting the compass, that's important. And then you'll cross, and then you join up those points where it's crossing, and you will see that that line again will be a perpendicular straight through the line. Okay, straight through the line, 90 degrees to the line, and we'll go through those 2 points. That's what you do. The key thing is not to reset the compass. So once you've drawn the line, the original compass, you just set that. Don't reset the compass. Place the needle there, above, below, and again over there, above, below, and join them up, and you'll have a perpendicular. So again, on constructions, you could have questions like this. So this is a typical sort of question that you might see. So this is talking about a scale drawing. It's important to look at the scale. So the scale is normally written in the bottom right-hand corner. So this one's talking about 1 centimetre representing 1 metre. It's talking about this girl Jane who's planting a tree in the garden, and she wants it at least 4 metres from the point C. So that's 4 centimetres. We've got to bear in mind. Nearer to AB than to AD. I'll talk about that in a minute. And less than 3 metres from DC, so that's a line, less than 3 centimetres from the line DC, which is that bottom line there. So again, it's 3 centimetres we're talking about, because the scale 1 centimetre, 1 metre. It says, shade the region where Jane can plant the tree. So we've got to bear that all in mind. All that's got to be thought about. So let's talk this first one first. So at least 4 metres from point C. So this is the critical thing about loci questions, very typical about loci questions. With this, what you've got to do basically is make sure that you do it at a distance. So don't worry about the fact that it says at least. you do it at that particular distance, because if you do it at that particular distance, then obviously you know the boundary that you need. So just off camera here, what I'm doing is I'm setting my compass to 4 centimeters. Why is it 4? Because 4 centimeters for 4 meters. And I'm going to place this needle here. I'm going to place it at the corner at C. So I hope you can see that, placing at the corner at C. And I'm going to draw an arc. So anywhere in there, that's where we're going to have the arc being drawn. So that is just 4 centimeters. That arc 4 centimeters. Just going to double check that because it slipped a little bit. So to make sure it's right. Yeah. So just try that again because it slipped a little bit. So to make sure I get that right. So here we go. Yeah. Okay. Yeah. So that's 4 centimeters there. So we're going to rub that out a little bit because it just slipped a little bit. I want to make sure I get it right. So there's the 4 centimeters there. Now. Then it says it wants you to do it nearer to AB than to AD. Now these are 2 lines. AB is this line at the top, and AD is this line at the side. So we've got 2 lines. The only locus we know with 2 lines is the angle bisector from earlier. This is asking you to do it nearer to AB than to AD. And again, this is the key question with loci. If you get things like this, you basically do it where it's equal. So you're going to draw an angle bisector to start with. So let's just draw that angle bisector again. Similar to earlier, you set the compass at a particular distance, it doesn't matter what. Place your needle in the corner at A. We're going to draw an arc. And draw an arc. This is very fiddly to do with the camera in the way, but we're going to try. And again, without resetting the compass, take the compass off the page. Place the needle on where the arc crossed the garden. And again, draw an arc, and again, without resetting the compass, place the needle over here. Hope you can see this okay. And we're going to get a point where it crosses. So this is the angle bisector now, that I'm going to draw. This is the angle bisector. Okay, and it's asking you to do it nearer to AB, sorry, I'll just flick it up again, nearer to AB than to AD. So there's the line AB to AD. So it's going to be on this side of the line only. That's where it's nearer to. That's where it's equal to. So that's why you have to draw an angle bisector, but it's going to be on this side of the line. The last bit is to say less than 3 meters from DC. So that's very straightforward because that's just a straight line. Okay, so CD, we're going to need to draw a line that's 3 centimeters from that. So again, this is just a straightforward. I might just take the pencil out of the compass for this one. So we're just going to draw a line that's 3 centimeters away. So we're going to mark those points on the edges. So I'm going to do it real quick. 3 centimeters, there's 3 centimeters. Okay, and then over here, same thing, 3 centimeters. Okay, really accurate, as accurate as we can, really, very, very precise. Just take your time over it. It's worth it because it will get you some good marks. And we draw a line straight through. Okay, and this line is 3 centimeters away. Now, just to be complete, I'm going to make sure that I show the examiner that I know my distances. So that's 3 meters there, just to show that. And then again, this is the 4 meter distance here we talked about earlier. So I've written these 2 distances in, just to show the examiner that I know what I'm doing. And then I want to show the region where Jane can plant the tree. So she wants at least 4 meters, so in other words, on this side of the circle. She wants nearer to AB than AD, in other words, up here. And she wants it less than 3 meters from DC. So the only part where she could really do that is in there. So this is the region that will be. And you could mark that with an R or something like that, just to show where the tree can be. It can't be in the circle, because it's got to be at least 4 meters from C. But that's where the region will be, is in here. So that's a good demonstration of a loci question. With all the loci being exercised, angle bisector and circles and so on, all that's exercising those sorts of things, testing all those sorts of things in one question. Here's another one very similar. So this is a very straightforward question again, very, very similar to some of the previous things. This is talking about 3 points on a map. Again, the scale, this time the top, bottom left-hand corner, 1 centimeter representing 100 meters, and it's asking you to do it 300 meters from point A. Equidistant, so they've actually used the word equidistant here. That means equal distances from point B and point C. So that's equal distances from 2 points. So that's a perpendicular bisector from the presentation earlier. Just to remind you, let's just see that real quick so you can actually see that. So here's the PowerPoint from earlier. If I flick up a bit, this is what we're talking about. points equidistant from 2 points. Equidistant from 2 points. That's why we're talking about a perpendicular bisector here. So we're talking about a perpendicular bisector, and it's going to be perpendicular bisector to these 2 points C and B, and then we're talking 300 meters from point A. So point A is over there. So let's do A first. So 300 meters it says. So I'm setting my compass, put my pencil back on my compass again, and I'm setting that to 3 centimeters. Why? Because it said the scale was 3 centimeters, or 1 centimeter for every 100 meters. We're looking for 300 meters away from A, so we've got to draw a line that's 3 centimeters, or a compass arc that's 3 centimeters away. So let's do that real quick. So again, I'm going to place my ruler, my compass in A, and I'm going to draw an arc all the way around, circle all the way around this time. So this is where we want all these points. Try really careful not to slip because the camera's in the way, but try my best. So that's a circle. Again, let's show the examiner what we're talking about. So that's 300 meters in what we're trying to represent. I'm just going to double check it is in fact 300. You can see that 300. Okay, so it's 300 meters there. So 3 centimeters, 300 meters. And then again, the points equidistant. Let's go back down to the question again. Equidistant from point B and point C. So this is the points A and B and C here. So I'm going to just turn the paper slightly so I can draw I'm going to draw a perpendicular bisector of these 2 points. So again, compass slightly more than halfway between them. So that's important. So slightly more than halfway, just like the perpendicular bisector from earlier. So I'm going to do that. Draw an arc. And again, take your compass off the page without resetting the compass. Remember, that is important. We're going to take the compass over to C, and we're going to repeat that process, drawing an arc. And again, they should cross. They do here and here. So we're going to join those up. So here we go, joining them up. And that gives me a nice straight line. Okay, and we're going to try and extend that straight line as far as possible for reasons I'll go into in a minute, but just extend that for you. That really would be great, but I haven't got the long ruler today. Okay, and that again will be a perpendicular bisector, so that's where it says equidistant from the points P and C. Those are the points that are all on this line. All of these points on this line will be the same distance from B and C. The last thing it says is on the map, show one of the possible positions for point C. We've got 2 positions that point C could be. Point T could be here, where it crosses the circle, or over here. So there's 2 points where T could be. I'm going to choose just one of them because it only says show one of them. So I'm going to say, let's just select this one. Okay, and then put a little point C, or point T, sorry, where it crosses there. So I'm just indicating that to examiner. Point T, again, 300 meters from point A, equal distances from B and C. We've followed the question, and that's as much as we can show. Okay. This last one now, before I show you a couple of other things, is to do with a scale drawing of a garden. Again, very similar to some of the exam questions I've seen in the past. This is a bench, this is a fountain over there. It says, again, scale, bottom left-hand corner. 1 centimetre represents 2 metres. These scales are important, you've got to pay attention. Harvey is going to plant a tree in the garden. The tree must be less than 8 metres from the fountain and less than 11 metres from the bench. So again, just like in the previous questions, we're going to do it at 8 metres and at 11 metres, show those 2 loci, and then we're going to shade the region where in this case the tree can be. So 8 metres, obviously 8 metres is 4 centimetres, so we're going to set our compass to 4 centimetres. So I'm going to do that real quick. Again, I'm doing all this off camera because it's a little fiddly with the camera in the way, so trying to do this off camera. But I'm setting the compass 4 centimetres. So I've set my compass 4 centimetres. I'm going to do that from the fountain A. Of course, we won't want to worry about doing outside of the garden, so I'm not going to worry about drawing out here. You could if you want, doesn't really matter. But I'm going to just draw, just to cover as much as possible inside my garden. It's a little fiddly to do. Take my time over it, really take my time. Getting a good purchase on the compass is quite important. It's really important that you get that right, so I'm just trying to do that. It does slip a lot sometimes, so you've got to be really careful, especially under exam conditions, that you've just taken the time just to make sure you're as precise as you can be. So I'll just try again. It's a little slippy today. It's 4 It's very hard with the camera in the way as well, I'll be honest. So there you go, that's what you need to do. Over here, and then again over there, and then over there. Okay, so this is now 8 meters. This represents 8 meters. So I'm going to just show that to the examiner. Yes, I know this represents 8 meters, Mr. Examiner or Mrs. Examiner, and I've shown this is 8 meters from the fountain. Again, the tree must be less than 8 meters from the fountain, and this is going to be less than 11 meters from the bench. So 11 meters, if we're doing this, is going to be 5.5 centimeters. So we're going to set this to 5.5 centimeters now. So slightly bigger circle this time. Makes it slightly more difficult to do, but we're going to try and do it as best as we can. And again, that's going to be like this. Again, try and keep within the garden if we can. Okay, so again, I've done it real careful, so just showing you I've gone to the extreme. And then I'm going to show the examiner that this is representing 11 meters now. Again, so I'll double check that is actually 5.5. So yeah, 5.5. And then this one, just check that's 4. Yeah. So they're saying that it has to be less than that, so the only place it can be is in there. That's where the tree has to go. So I'll put a little mark there to show the examiner that's where it goes. Okay, now there's 2 things I want to mention before I finish off, and that is if they ask you to draw angles. So I want to go back to that example I showed you earlier, the equilateral triangle. So earlier on we drew an equilateral triangle. This one was particularly, was just 5 centimeters long, said so in the question. The reason why I want to draw attention to this is because they may ask you to draw an angle of 60 degrees without a protractor. So if they ask you to construct an angle of 60 degrees, obviously the way to do that is to draw an equilateral triangle, because we know that all the angles inside of an equilateral triangle is 60 degrees. So you start with a line which you can draw anywhere on your paper, and then just repeat the process I did earlier to draw an equilateral triangle, and we know we've constructed an angle of 60 degrees. So that's quite important. So if ever they ask you a question, and I have seen it asked, for them to draw you a 60, or for you to draw them, sorry, a 60 degree angle, then each of these angles will be 60 degrees, 60, 60, 60 inside of an equilateral triangle. That's very important. Now, because we can draw 60, we can also draw halfway of 60. We can draw 30, and the reason how we can draw 30 is by angle bisecting this equilateral triangle. So if you were to draw a triangle, an equilateral triangle, this is 60, but then if we draw an angle bisector inside this equilateral triangle, you'd be able to bisect the angle at the top here and get 30. And then you could bisect again and get 15. So they can ask you 30 degrees, and they can ask you 15 degrees, and they can ask you 60 degrees. So if they ask you any of those, then you know you have to start with an equilateral triangle. I'll just say that once again so you've got it. So if you draw an equilateral triangle, that's 60 degrees. If they ask you to construct an angle of 60, that's the easiest way of doing that. But if they ask you to construct an angle of 30, then you start with an equilateral triangle and then bisect this angle using an angle bisector, which I showed you earlier. And then you could bisect that angle again to give me 15. So they could ask you to construct 15 degrees. I haven't seen that asked recently, but you never know, they could ask it. And again, you would just bisect it twice. So bisect the 60 and then bisect the angle again, and you'd end up with 15. The other angle they could ask you to draw is the angle of 45 degrees. And if they ask you to draw 45 degrees, I need to take you back to the very first example I showed you. So if you draw a point anywhere on a particular line, if you draw a line and then a point on that particular line, you now know how to draw a perpendicular. Of course, this is perpendicular, isn't it? We decided that earlier. It's at 90 degrees of line. If they ask you to draw 45, then obviously 45 degrees, you could start off by drawing an angle bisector. So if I just show you that real quick, just to show you how to do it again. So again, set your compass, doesn't matter what length. Take your compass off the page without resetting. Place it in the arcs. Let's just do that real quick. Really fiddly. And then over here again. Okay, and then you end up with a point here. If you to draw a line straight to P from there, this angle now would be 45 degrees because we bisected the original 90 to get 45. Similarly, you could bisect it again to get 22.5 degrees. So it is possible for them to ask you to construct an angle at 22.5 degrees, and you'd need to know to start with a perpendicular like this, and then bisect it to get 45, and then you'd have to bisect it again to get 22.5. So Those angles, again, the previous example was 60, 30 and 15. So again, you start with an equilateral triangle. And if they ask you 90 or 45 or 22.5, then you would need to start with one of these with a perpendicular and then go from there. Okay, I hope you found that really interesting. That was the Loci constructions module to go. We're coming up just for half an hour now, so I hope that was interesting and worthwhile. I'll be back in a week or two to do another topic, so I hope you'll find these really useful. Do keep revising, do keep trying hard. I hope you do well in the summer. Good luck, and thank you for watching.